Okay, the physics first lab is talking about Newton's second law, which is also known as the momentum principle, where we have the momentum of an object, or the change in momentum is equal to the net forces times the change in time. From that we can figure out the velocity. Our final velocity is described as equal to the initial velocity plus the net forces on the object divided by the mass times delta t. And from that we can also get our position. Our final position is equal to the initial position plus the final velocity times delta p. For my experiment, I used a baseball which I rolled across a table. Here's the baseball here, and I set my my coordinate system to be the origin to be at the starting position of the ball. So therefore, since the ball is moving to the left, it would have a negative velocity, so it's moving in the negative direction. And if I were to run it, you can see the ball moving, and it went for just under 1 second. Note that because it's moving in the negative direction, the graph has it moving in a downward direction because it's moving, because of the way I set up my axes. Okay, in Python I set up my the mass of my ball to 0.145 kilograms, which is the mass of a baseball. My initial position was at negative, I'm sorry, 0.00100, which was my initial position in the tracker as well. And my velocity I calculated as negative 0.87900. And that I got from the calculation of my first position minus my initial position over the time difference. So my initial position was 0.001, as I said, and my the next time step it was at 0.03, and this I got from tracker, and also my time step in tracker was 0.033. So calculating that out, my final value was 0.878, actually rounded up, 0.879. Meters per second, and that's what I used in my Python as my velocity vector. And then down here is my looping, where we calculated the new position at each time step by using the calculation that the velocity is the old velocity plus the net forces, which in this case is 0, times delta t, and likewise my ball position is the old position plus the velocity times delta t. And looking at my graph of my findings, it's pretty consistent. The model matches up to my experiment. The model is in blue and the experiment is in red. Slightly different because of the acting forces of gravity and friction on the table caused the velocity to decrease a little bit as time went on with my experiment. So as to the question of if we flip the axes in the experiment, what would happen? And so basically what would happen is, if you look at the graph, instead of decreasing like it had, it increases. So our velocity would become positive rather than negative. And the second question asked about the net forces added together to give us a zero net force. In this particular observation, I would say the two forces acting upon it were gravity as well as friction on the table, as well as the friction in the ball, the shape of the ball, of a baseball. There's different materials. So I would say that those would be the net forces that should end up adding up to 0.